All right, problem 33, page 160. This polishes off the sister problems that we're going to do for homework 10. You're assigned problem 34 on the same page here. Both of those problems are projectile problems. There's a reason that projectile problems show up when you're studying quadratic functions, and that's because the physics of projectiles leads to equations between the spatial coordinates and time, which are quadratic in time. And in fact, there are other equations associated with the dynamics that bring in the velocity and some of the spatial coordinates, which are also quadratic. So it's not a mistake. In fact, as long as you don't bring the frictional effects of air or whatever medium the projectile is moving through, if you don't bring that into play, these quadratic equations are actually quite accurate. So in this particular case, we've got a ball going up. Drawing's a little bit deceptive. The ball is actually going straight up, straight back down. And S of t, this 80t minus 16t squared, where t represents time, S of t is the distance above the ground at any time t. So you can see at time t equals 0, if I put in time t equals 0 here, I get S of 0 is equal to 0. The ball's on the ground and it's been thrown up into the air, and the questions that are asked is when will the ball return to strike the ground? And the second question is over what interval is the height greater than 96 feet? The ball's going to go up, go over 96 feet, pause for a moment, come back down, go below 96 feet. So we're going to find the time going up, the time coming down, subtract the two and get an interval. Something not unlike that. So quickly, problem A says, when will the ball return to strike the ground? S is the distance above the ground, so it's asking us to solve S of t is equal to 0, and S of t is 80t minus 16t squared. We shouldn't be surprised that there are two times at which the ball is at a height 0, when it leaves the ground initially and when it returns, because after all, this is a quadratic equation in time and might have as many as two solutions. So we're asked to in problem A, we're asked to solve this simple equation. If we factor out a 16t from both of these terms, 80t divided by 16t leaves 5, and this leaves t. And so just very quickly, we can see that this equation, S of t is equal to 0, is solved for the values of time equal to 0 and t equal 5. So this is the initial launch, if you will, and this is the return to the ground. Easy enough. The only thing difficult about this problem is I've sort of run out of whiteboard space, so I'm going to erase this this solution to part A to make room for part B here. Part B says over what interval is S of t greater than 96 feet? Well, again, S of t is the distance above the ground. When is S of t equal to 80t minus 16t squared greater than 96? Yeah. So in this particular case, what we're going to do, I think, is rewrite this equation or this inequality in the following manner. I'm going to write 0 is greater than, I'm going to put the 16t squared over here, I'm going to bring the 80t squared over to the right hand side. The 96t squared is there already. And to make things look a little simpler, I'm going to just divide every term by 16. I'm going to get t squared minus 5t plus 6. And then I'm going to do a little factoring to get t minus 3 times t minus 2 is less than 0. And so and so we could see that the 2 points at which this value becomes 0 is t is equal to 2 and t is equal to 3. These are the points at which, these are the points in time at which s of t is equal to 96. T equals 2 is when it goes over 96 feet. So the ball is here at t equals 2, and the ball returns from its maximum height back down through 96 feet at t equals 3. So that's the interval. T is greater than 2 and less than 3. Here we go.